Hello, a warm welcome from HGT University. I am Dr. Ashok Yadav, Faculty of Agricultural Sciences. Today we are learning about the breeding of citrus. Citrus is one of the most important food crops worldwide. It is grown in more than 130 countries, mainly in tropical and subtropical areas. Sweet orange represents about 60% of the total citrus production, being marketed as a fresh fruit or as processed juice. Mandarin represents about 21% of the total citrus fruit production and are intended for the fresh market. Conventional breeding in citrus by hybridization is hampered by its complex genetics and reproduction biology. Apomixis, partial pollen or ovular sterility, cross or self-incompatibility, high heterozygosity. Citrus constitute a major group of fruit comprising of mandarin, orange, lemon, pomelo, grapefruit, tangerine, trifoliate orange, citron, citronges, etc. Despite of interspecific and intergeneric hybrids, Polyceres and Fortunella are also belong to genus Citrus. There are three major centers of diversity in India. The first in the northeast, including Assam and adjoining areas. It includes pepidas, pomelos and their hybrids, citrons, lemon and mandarins, and other interesting types like Genera tanga, Soho santang, a sour fruit similar to the sweet lime, and Soho siam, a mandarin type. The second diversity in South India, indigenous type including Gazanima, Pichili, and some wild mandarin types. The third and northwest region and the foot of Himalayas, where the hill lemon galgal is common. The various types of mandarins, hybrids of pomelo, citron, lemon, that is kannakhatta, and rough lemon are found all over the country. In general, the wild types are more common in the foothills. Many of the progenitors of the citrus fruits are believed to have originated in India. These include Citrus latipis, Citrus lemania, Citrus carna, Citrus panivesiculata, Citrus madera. Many of these are wild types. Problems in citrus breeding. There are the three major problems which hinder the successes of the citrus breeding. Citrus being perennial in nature takes more time for bearing. However, this period can be reduced to a maximum of half by top working the seedlings on an old tree. Polyomyrone citrus is peculiar feature found in the citrus as the seeds consist of more than one embryo. In addition to the zygotic embryo, one or more, sometimes as many as 15 additional embryos are developed from the nucellar tissue called nucellar embryos and found in the embryo sac. Most often, the zygotic seedling is crowded out by the vigorous nucellar seedlings. For getting large number of hybrids, citrus breeders should select a seed parent known to be either monoembryonic citrus species or polyembryonic except Citrus medica, Citrus latifolia, and Citrus grandis, which are monoembryonic, restricted the choice of breeder and complicate the procedure required to attain the desirable objectives. Sterility in citrus is inability of the gametic or sexual reproduction. Prevalence of high generative sterility is obviously a serious hindrance in the use of horticultural parents by hybridization. Complete pollen sterility is problematic where proportions of the nucellar embryos are very high. High level of sterility often leads to production of seedless fruits, which is serious hindrance to the development varieties. Self-incompatibility in citrus and cross-incompatibility is the common phenomenon which occurs widely in citrus. Most of the varieties of the grapefruits, Citrus grandis, are found to be the self-incompatible. Besides, some varieties of the lemon, sweet orange, and mandarin exhibit self-incompatibility of gametophytic type governed by the oppositional alleles. The flower of citrus is actinomorphic, pentamerous, hermaphrodite. They having a anthers is more than 20 in number, ovary superior and pentacarpellary. The flowers are arising in the month of February and March. Floral biology of citrus is citrus take place during February to April in North India. Sweet orange and mandarin blooms only once in March. However, it is reported that sweet orange blooms twice in a year under Bihar condition, February, March and June, July. Inflorescence in citrus species is of cymose type. Generally, anthesis takes place in the morning between 9 to 12 noon. Flower on the shaded side of the tree have been observed to open later than those exposed to the sunshine. Breeding methods in citrus. First is the introduction. Introduction of the germplasm either from other countries or from one agroclimatic region to the other within the country has been one of the most potent improvement methods. The mandarin variety Santra is known to have been grown in India from many countries. It was introduced into the central province now in Maharashtra, Gujranwala in Punjab during 1880. The present century has been the introduction of the number of sweet orange varieties including Washington Neville, Valencia, Jaffa, Blood Red Malta and Tangerines. The first two were introduced from the America and the other from the respective countries of their origin. Grapefruit were introduced from the California and Florida, lemons from China, Malta from USA and Italy. Mosami seems to have been introduced in Nagpur during the beginning of the 20th century. The introduction of the Kinnu mandarin king into Bilulu in 1947 showed great promising in North India. It was introduced in South India in 1958 and Punjab in 1959 and has performed extremely well in Punjab. Colonial selection in citrus is exploitation of the natural variability excited in variety has resulted in the isolation of the some promising clones in citrus. PKM1 lime is colonial selection from the seedling progenies of the Kadayam type of the Tirunelveli district of Tamil Nadu. Yuvraj blood red is seedless and early maturing colonial selection from the blood red orange. Pramalini and Bikram, the two Kagri lime varieties were developed through the colonial selection at Marathwada University. Chakrata is a thornless and seedless selection from Kagri lime. Hybridization in citrus is confronted with real problems in citrus improvement both on the sign as well as the rootstock because the longitudinal phase delays the assessment of the hybrids. Most of the cultivated varieties are highly polyembryonic, hence the crosses made using these as females result in very few weak hybrids which are difficult to identify from the initial seedlings. Electrophoretic techniques separating the isozymes of the parent and hybrids may be great value in sand breeding program as no morphological markers are available at present. The heterozygous nature of the crop further leads to wide segregation. The problems are little less complicated of the rootstock breeding where the commonly used disease-resistant male parent Ponycius trifoliata has trifoliate leaf which is dominant over the monofoliate character in other citrus varieties and all the hybrids, by which distinction of unifoliate nuclear seedlings could be easily made. Hybridization technique in citrus, the mature flower bud on the female parent are emasculated early in the morning on the day of opening and are baked. The flower to be used as male parent are baked the previous evening. The next morning, as the day warms up, the anthers descends releasing the pollen grains when the flowers can be plucked to the pollinate the respective stigma of the emasculated flowers. The pollinated flowers are baked, opened after about a week and allowed to mature into the ripe fruits. In some cases, especially when the trifoliate orange is used as Male parent difficulties are encountered as its flowering is over before other citrus varieties flowers. Therefore, pollen has to be stored at the low humidity and temperature. Seeds from the mature fruits are extracted and sown immediately in the sterilized sand and soil mixture. Intergeneric and intergeneric habits, though intergeneric habits are rare in the fruit plants, much success has been obtained in citrus. Habits of Poniceous citrin. A group having the percentage of trifoliate orange, Poniceous trifoliata, and sweet orange citrus sinensis, the hybrids showed intermediate characters of the parents. The leaves are mainly trifoliate but unifoliate evergreen leaves are also observed in some plants. The fruits are juicy and flavored. Some cultivars are Trior, Carizo, Morton, Petonia, Rust, and Coleman Satrangiquate. This is a trigeneric hybrid of three different genera Poniceous, Citrus, and Fortunella. Satringa. The hybrids were developed by backcross citrins with the citrus sinensis. Sycitrins. Another backcross hybrid between citrin and Poniceous trifoliata into the Citrus paradisae. Citandrin. A hybrid between Poniceous trifoliata and Citrus reticulata. Citrimon, a hybrid between Poniceous trifoliata and Citrus lemon. Cytumiquate. This is the hybrid between Poniceous trifoliata and Fortunella japonica. Fortunella margarita are very difficult hybrid to breed. Hybrids of Fortunella. Number 1 is the Crossingquate. Crossingquate is the cross of triple cross with the F1 hybrid, that is Fortunella japonica, into that is Citrus arrondifolia cultivar Mexican into the Fortunella henderson. Limequate, the cross of Citrus arrondifolia into Fortunella japonica. Orangequate, the cross of Citrus reticulata variety Satsuma into Fortunella japonica into Fortunella margarita cultivar Meowa. Intergeneric Tangor, the cross of Mandarin into sweet orange, Citrus sinensis into Citrus reticulata, hybrids cultivar, Temple, Clementine, and that is the Montreal are some important cultivars. Tangelo, they are cross of Mandarin into grapefruit, Citrus reticulata into Citrus paradisae, cultivar, Orlando, Sampson, that is Manuela, and Simeonoli. Lemon, the cross of lemon into lime, citrus lemon into Citrus arrondifolia cultivar is the perennial. The lemonade, the cross of Citrus lemon into Citrus sinensis, that is lemon Citrus lemon into Citrus reticulata. Somatic mutations are common in citrus, and through selection of the natural mutants, quite a few number of the desirable clones have been obtained. The frequent occurrence of the chimera may lead to clonal impurities, and thus bud selection work in the propagation becomes important for the ensuring clonal purity. Selection of the natural mutants have been successfully employed for the seedlessness, season of ripening, Satsuma, and naval improvement of color, that is the rare ruby grapefruit in citrus. Besides natural mutation, many induced mutants have been developed in citrus. For instance, Star Ruby and Rio Red variety of grapefruit were developed in Texas, USA through X-rays and thermal neutral treatment of the seeds of the cultivar Ruby Red, whose red flash color faded at harvest. In Japan, a few closely related clones of Satsuma mandarin with varied fruit color and fruit ripening time were obtained through mutation. Polyploidy breeding in citrus of the species and varieties of the citrus are diploid, but occurrence of polyploidy has been reported in many cultivars. The Hong Kong wild competes Fortunella henderson may have been to the first reported tetraploid. Polyploid breeding seems to be the other prospects to the obtain large sized fruit with the dwarf plant types. Production of the triploid by crossing tetraploid with the diploid will be useful in obtaining seedless varieties. Biotechnology improvement citrus is transformation of the food species by biotechnology tools as a potential approach to the develop disease-resistant cultivars. Woody plants are known to be difficult to herbaceous plant, but citrus in is exceptional. Through the natural embryonic and citrus is of great value for producing vigorous, uniform and virus-free plants. It is appears to be the obstacle in hybridization. In polyembryonic cultivars, the vigorous growth of nuclear embryos inhibits the growth of the zygotic embryos and causes its degeneration prior to the seed maturation. Such abortive embryos can be rescued by tissue culture. Tissue culture has effectively been used in obtaining hybrid Poniceros plantlets from polyembryonic citrus cultivars. Poniceros typholata not only carry a genetic marker but also possesses resistance to the Tristeza, Phytophthora, nematodes and cold stress. Enter generic hybridization with the aid of cell of tissue culture offset possibility of incorporation of multiple desirable characters found in the different genera from improvement of citrus rootstock and giant cultivars. So today we covered the breeding of citrus. Next time we meet you, we will be exploring about the breeding of grapes. Keep learning, keep growing. See you next time.